Should I get up? You can all see me, right? So thank you guys for coming. We are starting this new chapter with Feedzai, and actually I knew that internally they were doing these meetups, the data visualization team here. So I challenged Bia to open these sessions to the public and to learn a bit more with them. So yeah, that's why we end up here, and please see.
Yeah, and we want to make one more announcement in the beginning. We finally have a website as well. It's a really basic one, but we're proud to have one, because the main thing and what's hopefully really nice for everyone is like we're starting to create like content for you, like a big list about like meetups similar to it, persons you can look into it, books, tools, and every stuff we already mentioned or what comes across, so that everybody can go there and have a big list, look up for things he's interested. And we also, it's totally welcome to hit us a line to say, hey, that's interesting, add this to your list. So that's just to mention for the moment. And actually while we're here is what you guys will do, like a data critique session, and then afterwards we'll talk about how to visualize uncertainty.
Yeah.
And so
I'll take it away.
Give you the word.
Thank you.
Yes, I do.
All right. All right. Cool, that works. So welcome everyone. Welcome to Feedzai. So I don't know if all of you are aware, but Feedzai is a fraud fighting company. So the idea is to detect frauds. This happens across many different verticals, many different types of clients and so on. So let's not focus too much on that. What I would like to focus on is data visualization in Feedzai. So Feedzai is organized in 3 main departments. So there's one called research, there's another one called product, which also involves technology, and there's customer success. Visualization is mostly in the first 2, so in research and product. In research, we mostly try to deal with open-ended questions and these more abstract things that we want to in the future explore, or small tests that we don't know if they're going to work out and we don't know where to put them. So we usually don't have too much consideration for integration and stuff like that. But that's where it starts in research, a lot of things. Product is, as the name implies, really what the company wants to sell to its clients. We have 2 very strong examples. We have Insights, which is about dashboarding, about providing BI to the clients. And we have the Genome, which, if maybe some of you read the tech blog about it, it's basically a tool to explore in a graph visualization, network graph visualization mode, the connections between the entities that make up a transaction, and to try to understand and to see the patterns of fraud there. This maps out to us by Rita and me being in research, Artur working in insights, and Liliana and Beatriz working in genome. So if you have specific questions about any of this, you can approach us. So as Sarah mentioned, she approached Bia to kind of, if we could make a session that, one of these sessions that we do available to everyone. We do this every 2 weeks. So basically we get together, we group certain links, certain things that we think are very interesting that have been coming up in Viz, or certain themes, we put them together. And then we do a session every 2 weeks where it's internal for Feedzai, but it's not only for Viz people. So it's internal, but open to everyone at Feedzai, where we try to come up with these things that we'd like to discuss, with what we have been doing. We talk a little bit about internal projects sometimes too. And we kind of generate a bit of discussion on Viz inside Feedzai. So this is going to follow more or less the same pattern. So this is the welcome. So welcome. Next is critique. What we usually do in critique is we take some visualizations and we try to say, okay, this works well for me, this does not work well for me, this could be improved, and so on and so on. Then we have a big block, which is the theme that we've put together that I just mentioned, which is visualizing an uncertainty. So this will have a lot of different aspects. I won't go into that right now. And then we have the community chart clinic, which is the openness of the parts of this session, which is about you coming up with the things that you want to discuss, if you have them, or if you don't, to contribute to what someone else brings to the table. Just one point, that everything here is supposed to be very loose and very discussed and very, like, you can interrupt me and we can discuss things, so do not worry about that at all. This has the added benefits / inconvenience that I also say random things, but we'll try not to go into that. So first, we're going to critique. We have two graphs, two visualizations that we want to share. I don't know if all of you can see it. I can try to zoom in a little bit. Yeah, this works. Yeah, more or less. So basically and here again, I will start this, but I expect you to say what you liked and what you didn't like. We have a combination of a stacked area chart and then a kind of a distribution of the last part of that area chart, which is why it's called stacked area alluvial diagram. So you see basically the mapping to all of these things and which parts of the accepted and rejected sections are for each country. This is the outcome of final asylum decisions. So, like, by country in the EU, as you know, refugees is a sensitive and important topic lately in the EU. So this is one visualization on it. So does anyone want to start with the first comment on this? Do you think that it works? Do you think that it doesn't?
I think it takes a little while to understand what is happening there. Mm-hmm. But once you got that, you have to ignore the center, and it's just nice to see the flow. It's very useful to see the link and everything on one page. Usually you would build two charts for that in development.
Yeah. Yeah.
It would be helpful if the countries were ordered you seem to have the percentage of positives.
Yeah, I think they may be ordered by percentage.
But they're not, right? No. So it's 40%, 70%.
No, by application.
Yeah, but this is even more confusing because actually Germany accepted 40% and UK accepted 57%.
Exactly. So UK should be higher than.
Yeah, but it's also like it's actually less people that are accepted. So it's a bit confusing, I would say, this chart, because you don't really see how much people are accepted.
It's also the amount of people that applied for. Right?
Yeah, it's by number of total applications. So you have 158,000 on Germany, and you clearly have lower values for each of the subsequent countries. So
I sorted by number of applications.
Yeah, by number of applications. But I do agree that the number of applications could be clearer so that you would see that the bulk is.
But also the Y scale could be clear, because it is not clear what the Y axis represents. It could represent simply the percentage or the total number. I still didn't figure out what.
Yeah.
Also about colors, I would not say that accepted should be red and rejected should be blue. It sounds like positive, negative relationship, then it should be vice versa.
Yeah, it has a bit of a contextual connotation, I agree, which is a bit difficult to run away from.
Is there a dynamic version or is just a static version?
No, this is it, I think.
We also have the stacked areas, which when you have the timeline, it's nice to understand the flow of the bottom one, but then you lose these not, unless that you have a peak like we have it between 16 and 17. It's not so clear what happened to the accepted ones between 12 and 14, for example.
I definitely agree that I think the Sankey part of it does not add too much, but I think what you were saying, that it's the kind of thing that usually you're presented into separate charts, and it's a really nice way to link them, I think, and you don't see that very often. And
I think
that's mostly the biggest pro of this chart.
Because I think the linking brings to kind of a clear statement that if you put together the pink parts on the right-hand side, you're going to come up with the pink side on the left. And that's like quite relevant in the sense that if you compare the two, you look that Germany is only 40% of their applications, but it's actually more than half of the total accepted ones. So it's a nice way also of putting that together. So, which in separate graphs you may not get to because you completely isolate them.
And it's that tricky thing of representing the relative and the absolute at the same time.
Yeah. Okay.
It's always a trade-off.
Anyone else want to add something?
I still have a problem with the figure, and I don't think I fully understand it, but I feel very strongly biased by that figure, and I'm still not sure what it says, that whatever Germany does has the most important focus probably to attract the German community to see what they're doing. But I'm not sure if I'm reading out of this that Germany does better, it does worse.
I think the point is that they receive a lot of applications, which is what you see in the bar. And that's a big chunk of the ones that are accepted actually are accepted by Germany.
Yeah, my question is why it's more like a general question.
Okay.
Like I see the numbers and why would I present it that way? If I would be an Austrian, if I focus on the Austrian data and I want, because here there's a point made about Germany, right? Depending on what question you want to answer, it's like 40% off. Yeah. While, for example, Austria, I'm Austrian, that's why I focus on it. As an Austrian, there are 56% accepted, which is from all the percentages, almost
second highest.
Yeah, second highest. So depending on which country I focus, that plot maybe looks different.
Yeah.
And that was just a comment. It's just that I'm still not sure what I'm seeing because I don't know what to focus, and it has a very strong bias on Germany. And not understanding the question, I think Germany is doing the best. I still don't know if that is true. So that is just my comment.
Yeah. I think a lot goes into what's doing the best and so on.
No, I mean, the gut feeling is, I don't understand the graph, but Germany does it right.
Yeah.
So that is my problem with the graph.
I think it just says like there the most people applied.
Yeah.
And we asked like, why? Why not applying in other countries? No.
Yeah.
No, that's
regardless of judgment, if it's
that's true.
I don't understand
you have to know what you focus on.
Exactly.
Yeah.
You can build
really
different if you want to focus on something else.
And also, if you have interactivity, you could solve some of the points that you are raising.
That's a good point.
So, one number for me is missing: the overall acceptance or rejection rate. Because you cannot, like, this would be, if I would have to present, I would say, okay, over the years developed until 300,000, I don't know, and 100,000 got accepted, that makes X percent. And if we drill it down to the countries, we see that Germany has the biggest chunk and is
the story
above this average.
Yeah. So I think those are all very good points, and I think it's true. What I think it's important to keep in mind is that it's not a graph in vacuum. It's a graph within the context, which maybe I should have mentioned in Financial Times. So I'm sure that there's a component of storytelling which probably goes with the graph. We can't actually access it because they block everything, but I suppose there would be. So let's move on to the second one. So the second one is, this has some time, but we really like this one, so we wanted to share it with you. So, and like here is, don't take it to mean too much. So this is an article on the Hollywood Reporter, which basically says the thesis is this, that in shadow of superheroes, Westerns are quietly popular. And then they go on to explain that like there was a dip in the number of Westerns and stuff like that in the 90s, but they kind of researched a little bit. And then the crux of the matter for us is that they build this visualization. So I'll let you look into it a bit. This is, just by the way, sorry. This is a year-by-year count of the number of American-produced Western films. Okay, so this is what they say about it. Okay.
What's the labels above the numbers? I can't read.
They're the year. So it's like 1960 is the top corner, and then 61, 62, 63, and so on.
Okay.
So, does anyone want to mention something? Yeah, that's a good one. So I usually, because I presented this before, and usually the way that I approach this graph is to try to layer the issues, because usually, like the first time that I looked at this, I saw some issues, and then I looked more and I saw others, and then I stopped looking because otherwise I would go crazy. But so let's start with something simple. Does the color palette work for anyone?
No.
All right. Okay.
Color friendly.
Yeah. So it kind of all mixes together. So that's one issue that we've also found, that it was not very particularly enlightening. Then I'm not sure about the next one, where to go. But so the idea here is to give perspective of movies are coming up. These types of movies are coming up in number and so on. And then you do a stacked bar. By each of these bars is basically the last digit of the year, because like each bar is like the O of 1960, 70, 80, and so on. Then it's 61, 71, and 81, and so on. So it's already a bit confusing. But then you decided to put it to 100%, which then does not allow you to compare numbers. Right. And I would just like to point out that 21 is bigger than 22. Or 25. So, yeah, or 25. So case in point, this is a bit like if you're talking about the number of movies, it's a bit hard to see them if you put them like this. Does anyone want to comment anything further?
It seems it happens the same of the years, because with the color from 1970 to 1979 on the second bar, below 1971 is behind. It starts before than the above bar. No, the above bar starts in
1971 compared to the 1970.
Yeah. Yes.
Yeah, that's the problem with having stacked. You have different places where the years start.
And it's really unfortunate when you want to see things evolve over time, because that's the point, because you can kind of do it for between 1960 and 1969, because you have it flat on the left.
Yeah.
But then other than that, it's completely impossible to do anything.
I think my very, very, very favorite point about this graph is how there's actually a decade, which is not a decade, between 2010 and 2016, which means that these three bars actually have one less decade in it, because they obviously didn't have the data for the last 3 years. So if you see, this is 2016, but this is 2007, because there's no 2017 at the point where they made this. So it's actually worse in that sense, because you're comparing like 5 different decades or 6, and then you're comparing 5 only, and so on.
Can we point a good thing about this? Like real good thing about
I like the font. I think the numbers are nice.
I think that's the interesting thing about this chart, because usually when we talk about bad Vs and ugly Vs, we see a lot of 3D pie charts and a lot of that, which are like in your face, that's a good option.
Yeah.
And this one, if you just glance over it, it actually looks visually appealing.
Yeah.
But then when you try to read any part of data from
the grid point of view, you look, everything starts in the same place, everything's finished in the same place. Pleasing. You don't realize immediately how bad it is until you even look to it. Besides the color palette.
Because I looked on it, I didn't even know how to start to read something. I even was confused with the lines and numbers on top of the years. And
that's the point that I believe was usually you immediately realize that it's bad for the information. Here, it's bad from the visual point of view. Here you look first to the image is not so bad as an image, and as soon as you start looking for information, you don't know even to start.
Probably this is data art.
Yeah. Abstract though.
Bit of Picasso one day.
So let's end on a positive note. And so this is a bit of what we do. We try to come up and try to find these examples, not necessarily bad examples. We just find stuff that we can comment on and have different perspectives on, which is basically what we try to do in this critique session. So next we'll go to the uncertainty, so the theme for the session and the big bulk of it. You will start there too?
Yeah.
Do you want to use this presentation?
Yeah. Okay. So the point of visualizing uncertainty is an important one for us for two main reasons. One is because it's important to use visualization can be a really strong vehicle of passing through the idea, but the other way around is also true. So usually when you look for a data point, we lose from our minds that in fact there are almost always there are some uncertainty about those points or about that line that we are showing. Okay, and this is the main point of this part of the risk. So associated to uncertainty and what uncertainty means, we have contexts of doubt or some situations of risk or even variability. Can be also associated to errors when we measure something or the sample is not representative of the population and so on and so forth. Lack of knowledge, lack of information, not perfect information, or can be also a way of hedging. And here we have a picture of how this could start from the data pipeline and will end up in a visualization a bit more broad. And this is usually something that even in data visualization sometimes we don't see. Right, we present a timeline with representing some kind of conclusion of a regression or a mean or something, and we lose the perception that there are a lot of questions behind that data. It's quite a strong vehicle to go through information, and it's hard then to put our brain out of the certainty that is not there. Okay, so here we have a bar chart, and from the certainty point of view, we can have uncertainty at the measure level, right? We could have also on the conclusion that we bring from this chart. So what will be the forecast? What will gonna happen in the next quarter? Let's say like that. Okay. Could also be related with the model that we have behind. If we are representing something that is coming from a model, why we choose that model and not other one? What is the confidence that we have on that model, and so on. And also, sometimes there are uncertainty about the decision. Okay, with this data, let's say that these are sales from 2 different quarters. What we're gonna do next? Will we expand? Will we open another store in another point? We can have a lot of decisions that coming from the data that we have in hands, and there are not one unique answer. Okay, so associated to the measurement, we have not sure what data are, and in this context, in several of contexts, this is quite true. Even in business ones, we can have the forecast that. We are not sure about what will gonna happen next. We can have scenarios. We can have uncertainty associated to weather, whatever. At the model level, we are not sure how the data fits together. And also, again, as I mentioned before, at the decision level, what we're gonna do with the information that we now have on hand. And this is pretty much what uncertainty is and how is this related with a visualization, and how sometimes we forget a bit of this because it's easier or it's strongest to just draw a line instead of a band or something like that. Okay, to start with an example of uncertainty and how this can be read and the impacts that this can have. I'm not sure if everyone already see this picture is a well-known picture. It was presented not so, it was discussed recently again for the hurricanes. So what the chart looks like is what we have here. So we have the hurricane at a given point of time in this position, and now what can happen, okay? So we have a line, we have a band of colors, solid color, and this is a way of showing the data. In the center, we have how the majority of people will read it, and the majority of people will read it in the following way. For sure, the hurricane has a deterministic trajectory. It will be on the day +1 in the first dot, day +2 in the second dot, and so far and so for it. And then it will be more spread from the wind point of view. So a bigger region, which will be effects for the winds and the rains and so on. And this is clearly not the case. And on the right, we have more what we decided to say, how should it be read? That is, in fact, from the real point of view, it can even end up completely outside of the first representation, because there are a lot of uncertainty associated to weather, even in this kind of strong phenomena. And weather is one of the areas where uncertainty is quite strong, and that we forget because we can even claim, we can complain about weather forecast, and we have, so even in Portugal, IPMA have 10 days forecasting weather, and after 72 hours, nothing of that has really statistical meaning, or at least a strong one. But we look for that, and we plan our life with 1 week upfront with the visualization that we have in hand.
Cool. Oops, spoiler.
So another example is the use of animations to represent uncertainty. So on the left, we have the needle chart, I think it was called that way. This was very controversial in the time. So this was done by the New York Times in 2016 by showing the results, live results of the US presidential forecasts. And so the pointer on this gouge or the needle was going left, right, and sometimes very fast. So there was confusing a lot of people. And so the movement of the pointer is basically showing how uncertainty are their numbers. On the right, we have the hops plots. Basically, these lines, these ones here, are going up and down in the region that we know that the point is there, but we don't know exactly where, but we know at least the region. Another example is the multiple outcomes is on the right. So on the right we have a warming stripe. So first, what is a warming stripe? This was actually very discussed on Twitter recently because of the awareness of increasing of the awareness of climate change. So basically, on the left, a warming stripe is we have a stripe for each year, and we are colored by red, which means warm, and blue, cold. And we can see the evolution of the medium temperatures. This is for Portugal, but in this link we can pick another country and see how is it. On the right, we have a warming stripe with projections, and showing the possible outcomes gives a sense to the reader that there is uncertainty in these results. So we have possible ways, outcomes to this. So going to trying to summarize possible different approaches that we have to visualize uncertainty. This was actually adapted from this blog post here on flowing data. And so the first one is ranges. I think it's most used one. So here on this plot, you can see these gray bars. So it's the confidence interval. So you use a lot the confidence intervals or error bars, but these and these ones are distributions. For me, it makes sense because I'm familiar with them, but depends on the consumers of your visualization. Maybe they don't know what are distributions or error bars, and then you have to have a lot of annotations for them to understand it. So it's the cons of these approaches. Multiple outcomes already discussed. So next, simulations. I think recently there's using a lot of this approach. So basically is when we are showing all the data at once or aggregated, and it's very difficult in that way to interpret the results. So what we do is to give so the reader an option to choose the variables that they want. For example, he can pick the gender and the year, and then we can see an individual outcome. And obscurity, which I don't find much in the literature, but I think it's an interesting approach. So here on...
It's hard to see in the literature.
So on the left in this picture, the lines represents the predictions and the opacity represents the strength of these predictions. I think it's interesting to use opacity to do this, but I don't see that a lot. And finally, well, maybe you don't need a visualization, but in that case, we need to be aware and avoid using absolute numbers and represent uncertainty in the numbers that we are using.
Okay. So on this topic of uncertainty, we've come across some examples, explain what it is, and as Viviana was just mentioning, kind of the few approaches that we've seen all around different areas of how to deal with uncertainty. And now I wanted to talk a bit about the state of the art. So people who are actually currently working on visualization research for uncertainty, and talking about this topic, it's kind of impossible to avoid talking about the Midwest Uncertainty Collective, or MU, which was recently formed, and it's basically a collaboration between Jessica Holman and Matthew Kay, who do a lot of research in this area. Just going to give some examples of the things that I've been working on. So I don't know if you have the app for Carir. It gives you an estimate of when the next bus is coming, and they give you exact values for when that is going to happen, and I can assure you it's never is. If you want to make a decision based on that, it's really hard, right? So you're waiting for a bus and you're wondering, do I have time to go grab a cup of coffee before the bus comes? And so you get an estimate, for example, for 11 minutes. You know the next bus is coming in 11 minutes. But because you're given this absolute value, it's really hard to make decisions. You know that this is probably comes from a distribution. However, many people are not aware of how to read if you just give them a chart like this. And so the goal of their research was, how do we make this interpretable for everyone, or easier to read? Yeah, so if you look at this and you know that I'll take around 8 minutes to grab a cup of coffee, and I'll be able, there's a 90% chance that the bus comes 8 minutes or later, so I'm pretty safe. But how do we make this more interpretable? So first we can look at the cumulative probability. So each point here is, for example, if I go here, I know that there's like a 75% chance that the bus will come at 15 minutes or later, or before. And so how do I transform this into something interpretable? So I can separate this in quantiles. So I'll uniformly separate the domain of the probability. And then I'm just going to map those values to the domain of time here on the bottom. And then it's pretty simple. You just count how many of these lines you have on each section. And so got 2, 1, and you got 2 dots here, 4 here, 5 here. And there are 2 great things about this approach. One is that it really approximates the shape of the distribution. And then the second one is because it's you've discretized it, it's easier to interpret for most people because we're usually much better at looking at units. So I know that if I arrive 8 minutes from now, I will miss those 2 dots, but I still have like 18. So I know that 18 out of 20 odds I'll be able to catch the bus. So this is a quantile dot plot, that's what they're calling it. And they've published a paper on it, they've done some tests with your regular commuters, and they've got some pretty good results. But if you want to get some more details about how the testing was conducted, just check the paper. Another example of a plot by them, and something that Liliana mentioned, the hypothetical outcome plots, which you've seen, kind of give you an experience of uncertainty. And as you can probably see, this kind of research is mostly focused on how do we make a concept like uncertainty, which, that has a statistical meaning, approachable for people that don't have a statistical background. So they're trying to make things more intuitive and give a sense to it for the someone who's doesn't really have a background on this area. So these 2 are, I put the Midwest Uncertainty Collective and IDL, the Interaction Design Lab from the University of Washington, because that's where Jessica Homan previously was. She still is. And this is a paper just from the Interactive Data Lab and also from Tableau Research. And here we're using color to encode uncertainty. And so if we look at something which would be a bivariate map of uncertainty, when we're using U to encode the color U to encode the data value, and then we're using saturation to encode how certain we are of that. But what they are proposing is to use something called a value suppressing uncertainty palette. And what this does is they give you more range in the areas where you're more certain, which makes sense because if you're certain of those values, you want to make sure that 2.1 is very different from 2.2 because you're very certain that that's 2.1 and that's 2.2. And in the regions where you're mostly uncertain, there isn't really a great value in making those data points visually different because you're not really sure that they are that different. For example, here, all these colors are visually distinguishable, but the data points might actually be around the same. So in this data palette, you're actually just giving them the same color because you just probably don't really know what they are. And they got some really interesting results. And so this is kind of an overview of some interesting research in this area of uncertainty. And I think it's always good to have a sense of what's coming up because that's just innovative ways that we can use and to make them more familiar to everyone. So I mentioned the Interactive Data Lab from the University of Washington. This is a really big group in terms of importance in this area. So they are the group they were previously at University of Stanford. They were called the Stanford Visualization Group. And this is basically where Tableau, which was previously known as Polaris, came from, D3 and Vega. So you can kind of have a sense of their impact in this area. The director of the lab is Jeffrey Heard, and they have a course at the University of Washington, a data visualization course. And this is a pretty great resource. So I'm just going to open the link to give you an idea of their program. So they have a really thorough course on visualization, and they have a specific part which is just on uncertainty, and they had for this year a guest, Michael Cornell from Tableau Software, which was one of the people involved on those color palettes that I've just shown. So if you want to learn more just about visualization in general, this is a great resource, and particularly on uncertainty, you got here some great place to start out. Most of the slides are available, and even some projects that they have, you can look at what other solutions. So you can try to do the projects on your own and see what their students who took the class actually did. So I think it's a really nice way to start out.
And it's good because it's by subject. So like every week or every kind of topic that they cover, it's very self-contained usually. So that's pretty interesting if you just really are interested in uncertainty or networks or something like that. You can just really go into that instead of like needing to take a whole course in order to get to what you want.
So this is also an interesting time of the year because IEEE is coming up. So there are a lot of new papers from these labs if you want to check them out. And I think this is it for uncertainty for a month.
Can you press the next one, Lily? It's really one slide.
Okay, so now on to...
Yeah, so basically this is the part that I mentioned where we can have a bit of a free discussion. If you have any questions or comments or anything that you'd like to put to the group, now is the time. If you don't have anything right at hand, I think Rita has one already.
Yeah, it's very interesting. I'm going to go ahead. We have been talking about how to visualize uncertainty, but my background is related to newsrooms. I used to be a journalist. And what I know is that people are not very aware of uncertainty, and they're not very worried about how to represent it and how to visualize it for, I think, two reasons. First, because they don't know uncertainty exists in the data. And second, because I think they think that if they represent uncertainty, they will lose trust in what they're trying to show. And one thing we would like to know is that if you feel that where you work at, if you think people are not aware of uncertainty, and how do you tackle that in your daily work? So feel free to join.
If you sorry,
go ahead.
I think it's not just uncertainty; it's probabilities in general.
Yeah.
For example, I work in restructuring, and there are people always afraid of too high numbers, of too low numbers if there's a minus in front. And if you show them a number, they cannot abstract and see what the probability or the possible range is. So they are really stick to the point. Just as with this hurricane projection there.
Yeah.
So yeah, and people get very emotional about that. So really, this anchoring works there.
Yeah.
And in fact, Beatrice was saying that it's easier to make a decision if we have uncertainty. It's the other way around. It's easier if you don't have, but it's harder to make a good decision. People usually don't like that. They prefer to have carries point and then just claim that carries don't know what they are doing or the weather, and then claiming that people from weather meteorologists, they don't know. And it's a bit related to that. And there are some of the visualization that we show, the animations as well, and even the other one that it was going up and down, and I'm not.
No.
Thank you. That they are important, for example, for business and so on, to people keep in mind that the values are not certain, that there are some uncertainty below, but it's harder because your brain needs to keep that in memory, that the values are flowing or that the values are jumping and down, and it's not.
I think that's a great point, and that's why I especially like the use of animation, because uncertainty is supposed to make you feel uncomfortable because you do not know. And I think that's one of the benefits of using animation is that what's going to happen next? I don't know. That's exactly the point of it.
And it's the point that we are raising, that when you want to make a decision, even if it's the wrong decision, you are comfortable that you get, I make the decision based on the number. So that's why I believe that also in our community, we don't show it so much, and we should show it much more, because it's the whole point. It's giving people information and not comfort.
But it's a hard balance, because in the end you're presenting something and you want the person on the other side to be
How do you test if it worked or not, the visualization? I mean, if you create what do you think it's a good visualization for uncertainty? How do you measure the...
Well, so in the one about the buses, what they did is they actually, I don't remember exactly how many people they tested with, but they asked people to just make decisions, just A/B testing with one and with the other, and how sure they were of it, and then you were able to compare both of them. And what you see a lot with the ones where you're just showing the exact numbers that people are very sure. Sometimes it's wrong because then you just take a simulation from the distribution that you're assuming, and you know that it's either going to work or not going to work. So imagine you see 7 minutes and the person for 7 minutes and it's actually 15 minutes. And the person who saw the quantile dot plot was like, oh, maybe I went to get a cup of coffee and I made it in time. But the one that saw the 11 minutes maybe did not went there. And when you took that 15 minutes out of the distribution, you were able to compare the decisions. And if you did that for a lot of simulations from the distribution, you're able to compare decisions.
I didn't read this article, but this paper in specific, but in visualization, the way of testing is pretty much this one. You have tasks that people are asked to do with the visualization, and then you can measure accuracy and speed of decision, how fast people decided on that, and if they decide accurate or not. In fact, it's because there are a couple of research, not a couple, several research on that, on pie charts, that we know that pie charts are not accurate, because people cannot, even if you are comfortable, or rainbow. So you have an idea, you test it, this one, and then on the business level, nowadays you can measure a lot of things. So you can also, in some situations, you have the technology to measure engagement. So are people using the visuals or not? Are they clicking here or there? And this can also give you a perception where people is looking at, or they are really using them to make business decision or not.
But I agree that that's a tricky one, because for the visualization, because it causes you to be uncomfortable, you're not going to get an answer like, oh, I like this plot more because it makes me feel less sure. It's not going to
You need the tasks, and you need to see, okay, are the decisions more accurate or not? And you need to count, for example, in this situation, that from the emotional point of view, people will be less willing to accept the uncertainty charts.
That's why there was so much controversy on the Gauss chart by the New York Times that Juliana presented. I mean, people on Twitter were absolutely mad about that chart, and the authors of it really defended it, because that's exactly what's supposed to happen. But again, controversy, and it's, I think, like Rita was saying, it's hard to balance those out.
And people were not used to it. That's what's shocking, because you need to get people used to it and then present them with something so stressful, which it was.
It's actually something kind of young for the public. I would say, this uncertainty chart, so they have to start to learn to read it. I mean, it's like, I just thought about like stock market, like earlier days, like years ago, I think you just trusted a person because he knows the market. So he was uncertainty for you. So you trusted that if he was false, you just blamed him. So now we get in the public with some charts we just experienced, and the people have to start to learn, and we have to research, like, of course, what fits. But I think it's...
Yeah, totally agree.
Probably it would be fun to combine the needle with the cone of uncertainty.
Just to really confuse people.
No, I think in many cases, for a general audience, risk is a better word than uncertainty, because they give it's more.
It's a business term.
Their needs and their problems. Uncertainty that they don't really know what.
But risk is a little bit one-sided, like at least in the perception of many people. It just shows the downside and not the upside. And that's like coloring one part in red. and the other in gray.
If you do a political poll like this, you're not going to call risk. Risk at party A or party B or whatever. It's complicated.
But in a business context, I think it makes sense.
And that in that example, coffee and the bus.
Yeah.
In the example of the coffee and the bus, I was thinking about that risk and all that, what maybe makes it more complicated, but specifically to that point, I would not only like to see when the bus comes and make the calculation how long the coffee takes. I would like to see how many people had this waiting period and were able to have a coffee. And based on that, like just by gut feeling, I would make a decision more than estimating that. But that is only specific to something that is so low profile, while in other situations, the wisdom of the crowd can be very dangerous. So I don't know.
Will you be willing that Google tracks you and realize how long you take? They do already, but
maybe not for Google, not for, but kind of applications that would notification.
But yes, and then is the visual part, right? Because then we could create an application and a chart that don't guide you don't ask you to do the math, but gives you a perception of colors or intensity that this is more risky, this is less risky. This could be the mean or the average of the decision that were successful. All this.
For the bus, maybe it's because of tracking problem, but just came to my mind when you go nowadays to a bank or something, you always get the ticket, and at a very specific bank, you can spend 6-7 hours waiting. Although they say they will give you a message 2 people before, which in my case was 4 hours before, which would have been 10 minutes before. So if I would have had data on that specific time, on this day, 2 people take 2 hours or 4 hours, then I would have decided if I... So it depends on the issue.
And I think it will help us be more okay when the bus doesn't come exactly 7 minutes and it's just 8 and 10. It's like, oh, it's late again. It's like, I was expecting it.
It's a very Portuguese thing.
And then there's a car parking shitty and the bus can't pass. So all this uncertainty on the bus drive itself.
So I just contradict you a little bit. I really didn't like the animations. Because but I am not the general public. I worked with uncertainty for a long time in distributions. But when I see those with the mean or whatever that was going, it seems like I'm not counting how often spending there or there or there. It seems like it's almost uniform along this, that the mean can be anywhere in here, when in fact, the normal distribution, it should be more close to the center. So with the animations, I lose this because I cannot remember where the line goes.
I think an interesting change to that would be if you saw, so you start seeing the different simulations from the distribution, and if you actually saw where the previous ones were, then you can kind of see, they're all faded there.
Some kind of lag with shadows.
I miss the discussion between what was it in Hurricane, in point estimation and interval estimation, because in fact this is the thing. And we always think that the point is right in the middle of the interval, and when it's not, that is the difficult.
The whole concept of intervals of confidence is very much
in Hurricane,
it's
the whole thing, because it's how the visual is built and how people perceive it.
I was using this example.
So it's the dots are the most likely. And then there are the interval, but we don't have the confidence as well. So even in reality, as you know, it can end up the center of the hurricane, the high of the hurricane can end up outside of that.
Like the one on the right.
So what the line, the border white line around the red part should be like 95% of confidence or so, is not even mentioned.
So sometimes people interpret that as 95% sure that the point will be in there. That's not.
Which is also a problem. Because all
the red region is where the high of the hurricane can be, and not the impact of the hurricane in the areas around.
In Statistics Portugal, there used to be a very known discussion about unemployment rate. So every month now you have unemployment rate, and the news say it's high, like 1 percentage point higher or lower. But in fact, it may be the opposite, because it's always between the range. And you see the news have big discussions about unemployment rate when probably it stays the same for 1 year. So this is also interesting when you have big discussions, theoretical discussions about movement of these point estimates, when in fact are always inside interval.
I was reading the latest book, Albert Cairo's book, and he discusses the kernel uncertainty. And he notes that not only that's uncertain, but that's uncertain not for the 95, but for the 67, which means that we are sure that 2/3 of the time the hurricane will pass that. So it's much more uncertain than people.
Yeah, I said 95 just as a figure, but it's usually whether it's. And in fact, these prints are from Alberto Scari's critique on New York Times. Yeah.
If we say that people cannot really read these charts and there are like statistical errors behind that, wouldn't it make sense never to show actually a discrete point, but always a range, if you're dealing with uncertainty?
There are two topics here. One is, are we doing this, or are journalists, or whether people doing this because they don't know what they are doing, or because they know the audience that they have and they need to make decisions. And of course, for me, it's clearly that is the second one. Or journalists talking about employment rate and explaining people that if I say 7 last year, but it was in fact between 8 and 6, and I say 8 this year and it's between 7 and 9, even if the uncertainty is the same, I can end up that last year was worse than this year, but I want to communicate that we are improving, and I want to clearly say that it's so. Sometimes it's intentional, other times it's just you don't want to cause the discomfort in people as well, because if everyone else is doing different, you can read it.
And I also think it's because people get used to showing things one way. And with the cone of uncertainty, I think that's the case. People got used to show it like that, and nobody really gave a thought on how to enhance it. So that's probably also it. And people got used to see it like that and got used to read it wrong, and it's a mess.
And there are also the time constraint that is nowadays people look for everything so fast that it's always a risk that if people are gonna spend the time they should. But it's for me, it's again the discussion that you raised and that we spoke about the bus. Sometimes people are more comfortable making the wrong decision, but this easier one, and then they can claim.
Yeah, it's a good example with the bus. Then would people be more comfortable if you would tell them the bus arrives between 1/4 and half past, rather than knowing it arrives at 20 past, so to say? Then they would maybe prepare earlier and organize that. So reducing the information and then the specificity of the information might be helpful here.
I think in that particular case, it might be a bit dangerous, because sometimes you really need to take the bus. So like what you want is actually the minimum that guarantees that you're going to take the bus. You're rather waiting 15 minutes than actually not getting it. You see my point? Mm-hmm. So like sometimes people, you can. I just don't know if people would read it in that way. if he doesn't show up in half an hour, you better walk. Yeah.
Yeah, I'll stop you.
Are you going to put this available?
Yeah, we'll share both the recording and the slides. Yeah. Can I now just? Oh, it's getting confused. No video. No. Come on, how do you make the big note? I tried to help, but I don't know German. I know. There's nothing with like showing my slides.
You made it once, so I'm sure.
Yeah, but where's the
Replicate the error. Or the
so I just click on it and it's done.
Can't replicate the
There's nothing like showing my.
one of those bugs like feature.
Why is it so complicated? Is it some light certain?
There you go.
But why is it here?
I don't know what you did.
Me neither. So I just remember that it's not really good picture, but anyway, it's from a newspaper here. You actually know, it's your magazine you were sending to me.
I bought it because it has very nice content, and I actually bought it because it has an article about how to visualize uncertainty. So it's in a September edition, actually it's a special one, but if you can find it in El Corte Inglés and so on, so I highly advise you to buy it because it has really nice content.
But I would just I remembered when you was talking about business and showing like the last year, like we made it like this, but there was some uncertainty, and now we want to show like how the next years go. And that was mentioned as one graphic who merged also a bit some different graphics, what I really like, or what they also point out as a good example, where they show like how the last year was, but also with uncertainty they had, and then how they predict the future, what can happen. So it was an example, just remembered when you talk about it.
Besides the solid line here, because it represents what really happened.
Yeah, in the past.
This was the kind of chart that I used to see when I work in energy industry for forecasting energy, because then you really want the fuzziness, because you have uncertainty of the forecasting level and mostly on renewable energies, and you want to buy energy in a market that is deterministic. So even the business decision maker needs to be aware of the risk that is taking by the uncertainty associated to that. So that is usually a nice way, and it works also on paper as well, because you get gray range, so you can also find in journal papers this kind of.
I really like the annotation that circles around the fuzziness. Here and there, it also explained it for a more general public.
90 out
so
of 100.
Yeah.
3D?
Sometimes it will.
Does it though?
You are not measuring.
Yeah.
You are grouping. So.
Okay, so I think we can leave it here. I hope we have some food left.
Yeah, I just can wrap it up.
Just quick notes.
Yeah.
Really.
So.
How do we change now to another screen? Wait. Why is it always No, I don't think. Here. Yes. So to say this.
Thank you.
Yeah. Okay, so to wrap it up, thank you for having this and for the first experience to share this 2 weeks meeting with us. And we'll see if we do it again. It'll be nice. I liked it. And 2 more
events that will be present. Actually, if you want to meet us again, so go to the SPT Day in Porto. And and in Luxembourg there will be this conference. It's more for administrative public sector, but it will be nice, and it's for free, so you only pay the trip there.
But the problem is it's already totally booked. We all got the email, I think, today.
But if it's like the meetups, you will have place like.
There's a waiting list.
Yeah.
You go for the drinks.
Yeah, but I mean, Porto is next weekend. No, yeah.
It's next week.
No, the weekend after, not this year, the next year. And there's still some tickets available. So, and it's close by. I think it's quite interesting. They already have the schedule up, so you can see all the speakers and stuff there. And yeah, we will be there. We will maybe report it and say thank you because we reached 500 members. And we, as we mentioned, have the website. So, and then as you said, I hope there's some drinks, chips, keep on talking.
If not, you can always drink coffee.
Yes.
Thank you, everyone.
Okay.
Thank you.